Okay, we're going to look at an example here and see a few different ways, a few different steps to go through this. Some students will find one way a little bit easier to understand. Other students will find some of the other directions we can go a little bit easier to understand. But I want to make these available to you, and you need to decide what works best for you. Now, first of all, when we evaluate this definite integral, we begin by looking at the antiderivative. And this is the first place where we have kind of a choice into what we need to do. First of all, we'll be using substitution. We let u equal what? Okay, that'll be our inside. And then du equals what? The 2x dx. Now, Professor Berger shows a little bit somewhat different approach here. He looks at the x dx and says, yeah, that's what we have here, and to get that x dx we have to multiply the du by 1/2. Okay, we can do that, so by substitution x dx becomes 1/2 du. Well, an alternate way of doing this, put that in parentheses and then say, if we don't want to look at it that way, maybe we want to look at it more straightforward substitution. Let's solve this entire equation for dx, and in doing that, instead of dividing by 2, we divide by 2x. And we end up with du over 2x equals the dx. So in this technique, we can use kind of more direct substitution, and then when we get to this part, x squared minus 4, we'll go ahead and use that as the u, so it would be u to the 5th, and then we'd have du over 2x, and then what do we end up with? X divided by x, those cancel, and we'll have the u to the 5th times 1/2 du, which again is what we would have done with Professor Berger's technique, and x dx is the same as 1/2 du. So either direction we end up with the same expression. Some students find it a little easier to do one direction, others find it a little easier to do the other. I just wanted to make sure, find the way that works for you. Now, this is simply finding the antiderivative, and top of the next page we'll go through that, but we need to remember we're not just finding the antiderivative, we're going to be using that to evaluate the definite integral. And again, there's a couple different ways to look at that. So we have our integral of u to the 5th times 1/2 du, or go ahead and pull the 1/2 out in front, antiderivative of u to the 5th du. Well, basic power rule there, we'd have u to the 6th over 6, and then plus c. Well, we'll find out when we use the fundamental theorem to evaluate a definite integral, we don't need the plus c. So what we ultimately get for our antiderivative would be 1/12 u to the 6th. Now, what did we say u was equal to? Okay, so we'd have the 1/12 and then x squared minus 4 to the 6th, substituting back what we'd chosen for u. And then the integral, we're evaluating it from 0 to 2, so now we can plug those in for x. And let's see, we'd have 2 squared minus 4 to the 6th power minus 0 squared minus 4 to the 6th power. And we get what? 0 minus, this one would be, well, negative 4 to the 6th power. Someone want to plug that into your calculator? I can't quite do that one in my head. So 4,096 on that one, and then go ahead and multiply that by 1/12, or basically divide by 12, and we get what? Okay, so negative 341.333, well, 1/3. However you want to write that. I'm not real picky on that, but we get this value for the definite integral. Now, an alternative way of doing this, right here, instead of substituting back in the x squared minus 4 for u, we can do a slightly different substitution. And in fact, we could look at it right up here. Now, our integral limits originally are in terms of x. The dx at the end of our original problem says we're evaluating this with respect to x from x equals 0 to x equals 2. Well, we said we're going to let u equal x squared minus 4 if x equals 0, u will be equal to negative 4. So up here we could say we're going to integrate with respect to u from negative 4 on up to, I guess we should say if x equals 0 here, and if x equals 2, u is 0. So we can change the limits of our integration rather than going back to terms of x. We go from negative 4 to 0, and at this point right here then we could say, again without the plus c, we don't need it with the definite integral, we'd be evaluating this antiderivative from negative 4 up to 0. And in doing so, we'll have the 1/12, like we saw with our other part, and then u to the 6th, as u goes from negative 4 up to 0. And what we will end up with, okay, f of 0 minus f of negative 4, well, that's precisely what we get up here. We just get it kind of in a different order, instead of going back to terms of x and then calculating what this is when x is 2 or what this is when x is 0. We do that first and then plug it into the antiderivative. So we still get the 1/12 of negative 4,096, which is still going to be the negative 341 and 1/3. Just a little bit different route to get there. So again, whichever way, Both ways work. The more we get into integration, the more complicated integrals we run into, the more different ways that we can do it. It's just make sure you do it one correct way. That's always nice. Doesn't matter which correct way you do it, just do it one correct way. Okay. All right, we'll get to going on this worksheet then.